Okay, welcome. In this video, I want to talk about how we can index and subset matrices in R. So far we've been discussing what is a matrix and how can we create matrices in R. Subsetting a matrix, we do very similar to the way that we subset data frames. We use the same syntax with the square brackets. So I first would define some matrix A, and then I can refer to an individual element in the matrix by indicating a single value for the row and the column, or I can indicate vectors for R and C that are going to pull off a number of different rows and columns and create a sub matrix. But we can do this in the same exact way. I can give a bunch of indices as a vector for R, and I can give a bunch of indices in a vector for C, and that's going to pull off those indicated rows and those indicated columns and create a subset that I'll call a sub matrix. We can also use the negative notation to exclude rows or columns as well. And we'll see some examples, but when we select a single row or a single column, then that object is actually going to be created. It's going to create a vector object as opposed to a matrix object. But I think indexing a matrix, this is going to be best explored using an example. So let's take a look at question 2, where we've got this matrix B. So B has 4 rows and 3 columns. So this is a 4 by 3 matrix, which is entered, which we can create with this first code cell. So just keep in mind, this is using the matrix function. We're going to arrange the integers from 1 to 12 into a matrix that has 3 columns. So then it knows that it should have 4 rows as well. And since I didn't set the by row argument to true, it uses the default, which is it arranged these values first down column 1, then down column 2, and then the last 4 values, 9, 10, 11, and 12, are down column 3. So here's our matrix B. And this first question in 2A is saying, let's select columns 2 and 3 of matrix B. So here I'm going to use the square brackets. It doesn't say anything about the rows that I want to pick. So I'm going to keep all of the rows. And over here, I can enter a vector of 2 and 3 to indicate I want to keep columns 2 and 3. And there we go. So this kept all of the rows, all 4 rows, but only kept columns 2 and 3. So it excluded column 1. So I could have gotten that output by saying -1. That's going to say remove column 1. And that gave me the same exact output. I could have gotten this subset as well by using the colon notation to say 2:3, and that would be columns 2 and 3. So all 3 of these methods should be familiar to you. We've used this syntax to subset data frames using column indices, and it works exactly the same with matrices. So that gives me a way to extract a subset of the columns. This, in question 2B, it's asking me to subset just some of the rows. So in that case, I would say B, and now I want rows 1 and 4. So I can enter that in a matrix, and I want to keep all of the columns. So I leave the column index blank, and that's going to by default keep all of the columns. So this should just keep row 1 and row 4, all of the columns of both of those rows. And that looks good since this was row 1 and this was row 4. So that subset a matrix that has 2 rows and 3 columns. So this is a 2 by 3 matrix. And in this case, I really can't use the colon because these are not these 2 columns are, or excuse me, these 2 rows are not right next to each other. So I need to indicate them as like discrete values in a vector as I've done here. I suppose what I could do, this would work, right? If I said get rid of rows 2 and 3, and that gives me the same thing back. So we have the same sort of syntax that we can use when we're subsetting matrices with indices. To C, this is asking me to subset both some rows and some columns. So I want to keep columns 2 and 3 of rows 1 and 4. So I'm going to say, let's keep rows 1 and 4, and let's keep from those rows just the values in columns 2 and 3. So this is one way that we can indicate that. And this gives me row 1 and row 4, but I only keep columns 2 and 3. So that's 5 and 9 and 8 and 12. So here I should have 5, 9, 8, and 12. So that looks good. Select all of the columns in B except for the third one. So that would be, I could do the -3 here for that. And that keeps columns 1 and 2 and excludes column 3. Looks great. And here we want to create a vector by selecting the second row. So if I want to just select one row, I could say B2 and then leave the column blank. And just notice that when it created this output, I'm not getting a matrix. This is displaying a vector. So when I extract just a single row of a matrix, it's storing it not as a row matrix. It's not a row vector, excuse me. It's not storing this as a matrix at all. This is a one-dimensional thing. It's a vector. And similarly, if I want to select just column 2, I could indicate the column over here. And this also stores that output, that subset, as a vector as opposed to a matrix. So when we pull off a single row or a single column, it stores that output with the data structure of a vector. When I pull off multiple rows or multiple columns, it's going to store that output in a matrix. And sometimes this is good. Sometimes you want to extract a row and you want it to be a vector. And sometimes you extract a column and you want it to be stored as a vector. There are often times when you're going to want to do some arithmetic with the entries in row 2, and it's going to be more convenient to store that as a matrix that has one row. And it's going to be more convenient to store column 2 as a matrix that has a single column. So if you want to extract a single row or a single column and store it not as a vector, but you want to store it back in a matrix, then there is an extra argument that you can use, which we've seen earlier, which is the drop argument. And the default is it sets drop equal to true, meaning that it's going to drop the matrix structure and store it just as a vector. But if I set drop equal to false, that means, hey, do not drop the structure type from being a matrix. Keep my output stored as a matrix. So if I run B2 like I did up here, but now I add this drop equals false command, excuse me, notice the output now is not the vector 2, 6, 10, but rather it's a row vector. that has dimension 1 by 3. So it has one row, 3 columns. It's the same values, but it's being stored as a different data structure. If I did b blank, comma 2, comma drop equals false, this is going to extract just column 2, and it's going to keep it stored as a column vector. So it looks different than the output that I had here. This was a one-dimensional vector. This is a two-dimensional matrix, just it only happens to have one column, but I am storing this as a two-dimensional object. It has rows and it has columns. It's just storing all of the values in a single column. So this is a column vector, but column vectors are special matrices. They're matrices with a single column. Okay, so we'll stop this video here, and then in the next one, we'll talk about how we can extract individual values from a matrix.